Hello, in this video I make a little intermediate video for this morph map system that I develop here in Tripscode. And Tripscode is a freeware project, and it is in the GitHub, and I develop it, and this is a little 3D program here right now. And the latest thing I wish to do, I got this animation system and rigging and binding and inversed cinematics and several systems. I have created this in the C language. And now the next thing, next big thing is the morphs. I have also this timeline here. That I can change my time frame, and later when morphs should be ready, then they need to be integrated also with timeline system. And how it looks really internally is that timeline uses keyframes to animate, and for morph maps and morphs, in those morph maps, the morphed position is created for objects, and those positions are then utilized as keyframes. Then we need to make a system that reads the percentage or the weight of a morph that is applied, and then it sums those positions up, and then combines them into a single new morphed position for the mesh. And then it is used as a keyframe, while this mesh is also animated with bones and transformers. And what about this morph system? Here I have created Morph List, and here can select this. It highlights also the vertices that are in the morph map, and also I can select those morphs, and then I can add them at the map to the morph map and morphs to the morph map, and later I can remove them. I also rename, and I can update them, and this updating means that I need to change the vertices here like this, and then I can update the morph map. This means that a new set of vertices are in the map, and I can make new morphs inside this map. And that is for the morph system. Here we see that this list is based on the deformers. Here we say that deformer tree. I can collapse it and expand. Also I can collapse and expand those individual maps that contain morphs. And underneath the morphs, the properties area lists the included objects that are affected by this morph. Really, this list is I have four new prime types for those morphs. They are really the former morph map. Underneath the former morph map are the former morphs, and the second type is object morph map, and underneath the object morph map are the object morphs, and they are interconnected. So to say this, the former type of morphs and morph maps act as containers for the object type of morph and morph maps. And they are interconnected, and while they are saved and loaded, also this interconnection is restored when loading. And this is the one type of list that we have. I created it, and it is, in my opinion, it is complete. I can also change the influence of those individual morphs. Here we see that on the top the former morph is listed, and those object morphs follow. And those need to be also later connected, for instance, so that I can change those object morph influences from the prime, the former morph that is here on top. Then I don't need to change every percentage individually, that I can drive them from above here. That this connection is to be made later when I decide how it's useful to use it. But the main thing is that the values can be changed, and then they are saved also and loaded also. So this internally it is ready, the system, for the morphs to happen. Then I thought that the second way to create this list is really that reflects the internal state is to list first objects, and then object morph maps and object morphs under the object morph maps for every object. And this could be another way, and I thought that when I see this item list here, I can list objects, cameras, lights. No, in the principle, this program is not ready yet, but the idea is the same. That when I open up this morph list, then I could probably have here in the side panel, for instance, the formers, and underneath the objects. And when we enter into morph editing mode, that this is also a little plan here, that those modes are listed here under the bottom line. Here we see, and I should append one more mode. This should be called maybe a morph mode or modeling mode. This is not true modeling in the sense this program, as for now, utilizes only ready meshes. But maybe in the future, but modeling program is a little bit different, because it constantly changes those vertex counts and the internal structure for the object. And when we start to create those morph maps and everything is like fixed in the numbers, then we can't change it internally, delete or append something there. This is rather difficult, and that's why this modeling approach is should be maybe it is possible, but it should be like isolated internal system that first creates those meshes, and then it looks if it updates any states in the animation part of the program. And modeling is also different, because it has intense undo system. It needs it. Really, animation part can have undo, but this is not that much of a necessity when and undo systems are very advanced. They are really need programs that are really developed at sort of high order, and that's why I haven't done it. I can only cancel some action that I have started with the right mouse button. Then when I start to rotate something, then I can cancel it with the right mouse button. Start to move something, then I can cancel it with the right mouse button. It jumps into starting state. This is like a cancelling action, but this is not a real undo system. And then I need this, let's talk about this maybe possible mode for the morphs modeling. that is necessary for the morphs to create those morphs. And I have also already something like modeling. This can happen with curves, because I have curves here. And when I go into alright, let's do it. I'll just cancel this vertice selection. I need to select those objects to affect selection. And I go into polygon mode, and I select this larger object as the first prime object, and Shift L. I can and with C I can convert into edges, and then I can convert into vertice selection. Control P. Now this object now has curves applied, and I just clean those selections here. When I go into subdivided mode, maybe I should apply these curves in the back also. Anyway, no, I can do it here. So this way curves are also possible here in this program right now. And when I go into curve mode, then curves are connected with this mesh with CPs. Those are control points, and I can for instance in curve mode I use vertice mode, and then I can select a control point and manipulate it, Shift G, and then I can drag it. And for instance, it's similar the idea to the morph modeling. Why I'm talking about this curve modeling, because the modeling commands and control structures inside the program are similar, and when I start a new feature, then I look for the most latest recent thing that resembles those tasks and objectives that I wish to achieve. And this way I can, for instance, drag a single CP. And this is one way to model, simply dragging it to a new position. Simply I cancel it with right mouse button. But another way is to use those curves in whole, and then I can, for instance, scale it. It doesn't look good because it has already this animation rig applied. If I scale it, Control F was to freeze those coordinates, I guess. This scaling didn't happen. I need to be in okay, Shift R was maybe a Alter. Right. Okay, in bind mode it found. I did scaling it the wrong way. The real scaling, when I'm in curve mode, then I need to be in polygon mode. Then I can scale the selected curve with S, or not. I don't remember exactly. I need to be locators off, maybe. Locators were... and now I can scale. Huh? No. Alright, I have all the curves selected. I should select only one curve here in object mode. Select, and this was the effect that I was talking about. Then the effect of scaling a single curve inside the object, and also Shift S is rotating. Then I can rotate. This is already a modeling task, and then I constraint with numeric buttons those actions. Okay, when I go into bind mode, I see. It is better to create those. Why it was so messy here? I guess it is because those transformers affect this mesh, and it is better to model beforehand, before the rigging and setup is done with those, I think. And this was the example that shows that I have already some systems that support manipulating those vertice positions. And maybe when adding new mode, then I can look up those functions and places where this happens inside the program. And let's close this program and take a look at the code here, and where those manipulations take place inside the code. This is the main function, and I have a single C file, and the rest of it are H files, meaning like header files, but I don't create those specific files for function declarations, but I create those H files also are really as true C files. They include all the definitions also. And in the main function, I see, when I scroll here, I see a part when in the main C file, the main function starts here. When I see this blue case block here, this means that here those key presses are tested, and this is the STL framework here for this program, and this the main function here starts, and I can this is a familiar difference in the picture I see when it starts. Here first are those UI buttons. Some of them functions are bound for the buttons, and later the event loop starts, and those key presses and mouse actions are tested. And when we think about modeling, this is all about mouse actions, meaning mouse motion and mouse clicks, and where this happens. We see here some events that are handled, and when we see mouse button down, this could be a scrolling, not this is the mouse button down. What is made then? The scroll wheel is handled. Scrolling takes place when dialogues are open, and when dialogues are closed, then it affects some camera properties, maybe. And Then we see what is happening when the right mouse button is clicked. This means cancelling the motions and events what I started that I wish to cancel. Then I press right mouse button. I can do several things here. And when something was manipulated, for instance, manipulation is moving, rotating or scaling, and I can see here the manipulation actions that need to be taken to reset to the state before the action was started. And when the action is started, something is recorded into a state, and when the action is cancelled, then the state is restored. And here we see something in connection to the cancelling. And in various circumstances, what should be done. Then with the left mouse button we start usual things. And also dialog handling is here in this if-else block that is collapsed. We see this line. This is a very large block. We see here maybe 100 lines are inside this block. And then we see when dialog is handled. Those are the dialog clicks that we can do, and we collapse this one. And then we see handling of element selections here, and when we collapse this one, and then we see mouse button up. What we should do when mouse button is raised. This mouse click consists of two things: mouse button down and mouse button up. And mouse button up is then handled here. This is also important. And then we see mouse motion. And for the motion part, when mouse is moved, then I see, for instance, properties panel is open. We wish to change a color value or some other value there that is editable. Then we need to handle this mouse motion. It starts with a mouse click, and then I drag the mouse, and mouse motion is handled. This here starts with this motion handling. And edit properties means that properties can be, some of the properties can be typed in. This means the edit properties mode, I guess. If not edit properties, when we are not typing, using our keyboard as input device for to change those values. And inside this negation, then we see here those dragging actions that we have here. I just collapse them one by one, and we see then it becomes the properties handling. If properties panel is open, meaning it is not properties none, not rectangle is dragged, then comes this properties handling here, and collapse it also. Here we see other events that are handled with in connection with mouse motion. Also drag rectangle, I collapse it. And after the drag rectangle, I have this block of mouse button down, and meaning mouse button was clicked, it's not pressed, but as we I don't know what this one means here, but anyway, this is the element selection block, meaning I can click and drag on the elements and they become selected with IDs that are rendered into a background layer. And I drag and click and drag over an element with a cursor, then those elements become identified with background colors. They are just grayscale, but anyway, they differ by a number, and then it means the next element in this possible row of elements. And where is the object manipulation block? I'm searching for it. Mouse motion, meaning as if drive timeline. Okay, this is element selection. Okay, element selection. I need to find this where this because when we manipulate elements, then this constantly the view gets updated with manipulated rendering, and this involves the projection of the mouse cursor into a viewer space. And this one was interesting because it is very tedious, depends on the view type, and it makes sense to have this code only once in the program because it's very unique and very long, and that's why we should use the same code for planned manipulations. And just search for this one. This one is the camera screen lock block for it. And this camera screen lock is, and it handles the different view types. This means that something is manipulated, whether a camera is manipulated or vertices or elements or objects or transformers are manipulated in the program. This one is the manipulation block here in the mouse motion. And it starts with identifying this locator that is current, and then it jumps to the view types. If it's split view, then it handles those 4 types of views that we have. I have this split into 4 views when it's split view. But when we think of the morph manipulation, then I got this idea that it's a very good thing that should be split with half vertically. And on the left side there is untransformed object, and on the right side there is a specific pose that is already in the object, in the former. And when we then manipulate the morph map, then we should be able to see both results with untransformed, undeformed object on the left maybe, and on the right side we should be able to see transformed and deformed object. And those are then the view types. And when we have this new mode, for instance morph modeling or modeling mode, whatsoever we call it, then we should have here a different type of split also. And this is the else block. This means the single view right now. And let's take a look at this else block here. This means the single view code for the single view manipulation while mouse motion happens. Then we see very complicated and tedious code, and in different cases when scaling, rotating and moving here. And it calls those functions then that are connected to this those actions. And we see that moving is very much more difficult and tedious than those other routines. We see move is else, and we see that move handles a lot here. And here we see also this projection code with WinZ, meaning that here it uses some GL functions to unproject a point into a view plane or something like this. I created this code for a while ago, and I don't exactly remember, but I remember that this was very intense work, and it was very much of a study that I was investing into it. Unproject screen point, and it uses this WinZ plane, and I don't know what here is, but let's scroll it further and just highlight this one to see when it ends. We see drag buffer. This drag buffer means that OpenGL is able to unproject those mouse coordinates into a 3D space, and this happens like a certain distance viewer depth plane is rendered, and it is rendered across manipulated point or an action plane, so to say, and it is perpendicular to the camera, meaning it fills up the viewer plane, and then on this plane happens this unprojection. This is sort of explanation as much as I remember it. And because this code is so unique and difficult, that's why we shouldn't change or implement another method, but we should rather use and change this code. And even when new things are happening, for instance, if somebody plans to create a really morph modeling there, then we should utilize those actions inside mouse movement. And here also this axis lock means that we can constrain the movement to the cardinal axes but when we think of a modeling, then we should have maybe an also option to constrain it to the point normal that we are manipulating, or group normal. This could be also an option to create here later. And here we see some coordinates manipulation, because with different projections those numbers tend to, or those values tend to flip over, and I don't know what it exactly is, but and later finally we see this make movement function. This ends the movement block. And this else, this means that camera is manipulated. They are not objects or elements, they are just camera. And let's take a look at this make movement function. We just go into implementation. And this is also in main file here. And make movement then first off tests the bind pose. This is a binding mode inside the program. And then those movements are differently handled, and involves also bone creation here. In the movement involves also such things when I start to create bones, then I press B, and then this mouse movement projects the new final transformer for the bone under the cursor. And here we see what is in curve mode, and the CP manipulation. This is the part of interest, of course. And curve mode and curve manipulation. This is the inside the make movement function. And those are the places that we should then investigate when we plan to add new code. Then we take those old examples, old code, and then we look what is different and how we can reuse it. And here what happened in curve mode when we we see and then finally in movement we see when we displace a transformer in the view, then what it should do when the transformer is part of a bone or inside already affecting the deformed mesh. What should be done in this case? And also here we see object curves updating everywhere. This means that when those objects are transformed, then vertices become into new positions, and those new positions then are transferred to the curve CPs, and then the curves are drawn around those objects when they are deformed. But when we have those morph modeling, then we should do probably the same thing. Then those CPs get those coordinates from vertice coordinates, but when we model with curves, then those vertice coordinates get their positions from CP coordinates. If I remember correctly, I don't remember it very well. Everything that I say when somebody develops it should check exactly what is it's doing. And I just start up. I got a little bit confused with the previous thing when those this geometry was messy. Then I wish to check when I just import the zero object and I increase with page up the subdivisions. Then I select polygons, 2 polygons here. With drag selecting this was Shift L to select those polygons. And I press, then I can flip with F to the back side, Shift L. And I flip back, press C twice to get those vertices selections out of edge selections, and I press Ctrl P to place curves 4 times. I flip it over. So we see that those curves can affect the shape of the object. And I just do it because I wish to be certain when I manipulate a curve what happens. I go into curve mode, and I should be in object mode probably, and I escape, deselect it, and I select a curve, and with S I wish to change. Alright, it doesn't look very nice while I'm manipulating it, and that's because of when I press Alt P I should get the alternative. Alright, Alt P is the thing. I should have the patches mode in the curves, and when I press Shift E, then I just apply the weighting or what. Okay. Alright, I have changed the shape of the object, but when I wish to freeze this shape, then I press Ctrl F. Then it's frozen and it has a new form, this object. I could also select those vertices and manipulate this way. I must Ctrl F.